Hey there, my name is Mercedes Oada, and welcome back to Bio Radio, where today we will be discussing PAI-1 Deficiency. As described by Seals, Gupta, and Shapiro, plasminogen activator inhibitor 1 deficiency is a rare inherited autosomal recessive bleeding disorder characterized by excessive clot lysis leading to a moderate lifelong bleeding diathesis. But before we get into what it means to have a disorder resulting in the lack of PAI-1, let me first explain to you what PAI-1 is. Plasminogen activator inhibitor type 1 is scientifically defined as a single-chain glycoprotein produced by endothelial cells and hepatocytes. PAI-1 is a serine protease inhibitor that functions as a principal inhibitor of tissue plasminogen activator, also known as TPA, and urokinase, known as UPA. These are the activators of plasminogen and hence fibrinolysis. To put it in simpler terms, let's break this down. Plasminogen is the inactive form of plasmin, which is found in blood. UPA and TPA are the agents that activate plasmin, and in converting plasminogen into active plasmin, they allow fibrinolysis to occur. Fibrinolysis is the physical breakdown of blood clots. This process breaks down blood clots so that they don't accumulate and become problematic. So, active UPA and TPA means active dissolution of blood clots, and therefore free-flowing blood. However, we don't want blood clots to be dissolved too quickly, or else injuries of all severities would result in an excessive amount of blood loss. This is when PAI-1 kicks in. PAI-1 is a protein activator inhibitor. This means that it binds onto UPA and TPA, which are the activators of plasmin, in order to make sure fibrinolysis does not work too quickly at dissolving blood clots. This ensures that clots remain intact until they are no longer needed to stop bleeding. The lack of PAI-1 protein allows plasminogen activators to dissolve blood clots prematurely, which indicates a bleeding issues. Such results can be seen in people with PAI-1 deficiency. The question now is, how does one wound up with a disorder in the first place? Well, complete PAI-1 deficiency is caused by mutations in the SERPINE1 gene. The SERPINE1 gene is what provides instructions for making the plasminogen activator inhibitor 1 protein. The SERPINE1 gene mutations that cause complete PAI-1 deficiency result in the production of PAI-1 protein that is non-functional or that is unstable and quickly broken down. As I explained earlier, PAI-1 is involved in hemostasis, which just means normal blood clotting. Therefore, the absence of functional PAI-1 protein allows shortened lysis time for the dissolution of blood clots, resulting in the abnormal bleeding associated with this disorder. This condition is inherited in an autosomal recessive pattern. This means that both copies of the gene in each cell have mutations. Whether someone has partial or complete deficiency is solely determined by the specific mutation that has occurred. Considering mutations occur at random and are not instructed nor controlled, complete or partial PAI-1 deficiency cannot be predetermined. In the rare cases, however, that partial PAI-1 deficiency has appeared to be autosomal dominant, scientists have not yet identified the genetic causes. In human genetics, a carrier of a mutation is a person that has inherited a recessive allele for a mutation, but usually does not show symptoms of the disorder. In this case, the carriers would be the parents of an affected individual. Each parent carries only one copy of the mutated gene, so only one SERPINE1 mutation, but they typically do not show signs and symptoms of the condition. A diagnosis of PAI-1 deficiency may be made based on evaluation of symptoms, various blood tests, and genetic testing of the SERPINE1 gene. Diagnosis is found earlier as well as more frequently in females because of its effects on menstruation, pregnancy, and childbirth. That being said, because complete PAI-1 deficiency is autosomal recessive, it is inherited equally by both sexes. Now that we know where to genetically find a PAI-1 deficiency, let's look through a bigger epidemiological lens and find out in what groups of people can this disorder be found. As funny as it may sound, PAI-1 deficiency can be referred to as a private mutation, as it is designated to a very specific group of people. PAI-1 deficiency is a rare disorder found within an extended family of Old Order Amish who live in Bern, Indiana. This mutation originated in Bern, Switzerland within a specific group of farmers. Back in the 19th century, descendants of these Swiss farmers introduced this mutation to an Amish kindred as they emigrated to Bern, Indiana. Due to the fact that the Amish kindred in Bern, Indiana have been genetically and culturally isolated, the SERPINE1 mutation is not found anywhere in the Amish community outside the Bern area. As a matter of fact, the first genetic defect was discovered in 1992 in a 9-year-old girl from an Old Order Amish country who nearly bled to death during what should have been a routine scalp surgery. On that note, let's go over some of the other symptoms that are associated with this disorder. The excessive bleeding is shown to be evident in menorrhagia, also known as heavy bleeding during periods, abnormal bleeding in pregnancy, and childbirth. Other symptoms include the delayed healing of wounds, especially after a surgery, persistent nosebleeds, easy bruising, and bleeding in the joints. Some people with PAI-1 deficiency may even have cardiac fibrosis, which is scar tissue in the heart, which can lead to heart failure. Up until this point, I've only mentioned the negative effects that unfortunately come with this mutation. PAI-1 deficiency, however, isn't all that bad. According to a study done by the Northwestern University Feinberg School of Medicine, people of Indiana Amish kindred with PAI-1 deficiency live more than 10% longer. In general, individuals with the mutation live to be an approximate 85 years, comparable to their predicted average lifespan of 71 years. And you might be asking how? Well, the Amish individuals that lack a PAI-1 protein are found to have 10% longer telomeres than that of Amish with two PAI-1 proteins. But what does this mean, and how does it make them live longer? Well, a telomere is a repetitive sequence of nucleotides found at the end of our chromosomes that act as protective caps. A great analogy described by TA Sciences is comparing telomeres to the plastic tips at the end of our shoelaces. Without the coating, shoelaces become frayed until they can no longer do their job. Just as without telomeres, DNA strands become damaged and our cells can't do their job. In addition, individuals affected by PAI-1 deficiency are completely protected against diabetes. Carriers of the gene mutation were found to have nearly 30% lower fasting insulin levels. A high level of fasting insulin indicates insulin resistance and can encourage a person to make changes to lower it. So low fasting insulin levels as seen in affected individuals means strong insulin presence. This is good because insulin helps control blood glucose levels by signaling the liver, muscle, and fat cells to take in glucose from the blood. Insulin therefore helps cells to take in glucose to be used for energy. If the body has sufficient energy, insulin signals the liver to take up glucose and store it as glycogen. This is why individuals with type 1 diabetes need to inject insulin. In fact, this trait of lower fasting insulin levels that is shown in individuals with this mutation is so desired that Northwestern University has partnered with Toku University in Japan in order to develop an oral drug that inhibits the action of PAI-1 to achieve the effect it has on insulin levels. Lastly, specifically the elders of the Bern Amish community possessing the mutation show healthier cardiovascular systems. Benefits include a lower blood pressure and more flexible blood vessels that change with age. Now, before I go, let's just quickly go over what we've covered in this video. Today you learned that with PAI-1 you win some and you lose some. PAI-1 deficiency is a very rare genetic mutation that causes excess bleeding. We looked at the cause of this deficiency rooting from mutations in the SERPINE1 gene, leading to non-functional fibrinolysis inhibiting protein, also known as PAI-1. We also looked at benefits of this disorder, which in shorter terms is an overall prolonged life. While we have not yet identified any cure in this video, rest assured that you know just as much as science as a whole knows. Don't fret. Thanks to our ever-growing technological advancements in the medical world, we're only a couple medical trials away. Thanks for joining me on Bio Radio. Stay tuned for next week's video.